Trading standards have confiscated a suspected counterfeit consignment of hair products. Enforcement officers are concerned that the products might be harmful if the ammonia content is above safety standard levels. A sample bottle has been sent to the trading standards testing laboratories for analysis to determine the exact amount of ammonia in the product. Ammonia is a weak base, and so only partially reacts with water to form an equilibrium mixture with ammonium and hydroxide ions. This is represented by the equilibrium arrow on the chemical equation. When ammonia reacts with a strong acid, such as hydrochloric acid, it is fully protonated to form ammonium and chloride ions. When a base receives a proton, we call the species formed the conjugate acid of that base. In this example, the ammonium ion is the conjugate acid of ammonia. A titration experiment with hydrochloric acid and ammonia is an example of a strong acid, weak base titration. If we represent the titration data using a graph of the volume of hydrochloric acid solution plotted against pH, it gives a characteristic titration curve. As you add the hydrochloric acid solution, the pH initially decreases quickly. This is because the hydroxide ions already produced by the ammonia in water are neutralized by the hydrogen ions from the strong acid. The slope of the titration curve then begins to decrease at a slower rate, because now the ammonia needs to produce more hydroxide ions in order to re-establish the equilibrium. The hydroxide ions produced continue reacting with the strong acid, gradually decreasing the pH of the solution. When all of the ammonia molecules have reacted with water and the hydroxide ions have been neutralized, there is a sudden decrease in pH. This is because the hydrogen ions that are being added from the strong acid are no longer being neutralized and the solution quickly becomes acidic. This sharp decrease in pH indicates that you have reached the end point of the titration, which we can visualize using a suitable indicator compound that changes color within the required pH range. During a titration experiment, the exact point at which the mixture of acid and base are in equal proportions according to the balanced equation is known as the equivalence point. The pH at the equivalence point of a strong acid weak base titration is less than 7. This is due to the production of the conjugate acid during the titration, which makes the final solution slightly acidic. As an analytical chemist at the testing laboratory, you will need to determine if there is a harmful amount of ammonia in the hair product. You will need to carry out your analysis accurately and efficiently, as your results may be used as evidence in a court of law. In this activity, you will learn how to set up and run a titration experiment using a strong acid and a weak base.